electric motor used to move a variable load. The motor is connected in series with a battery and with an ammeter. The battery is going to be providing a fixed potential difference, and the ammeter is going to be measuring the current through the motor. In part A, we had to discuss what happened when the load was zero, and we said there'd be a very, very small current because there was such a big induced back EMF. Part B we're doing now, we've got to explain why the motor current increases when the load is increased. Now, I did cover some of the theory for this in the answer to part A, so if this doesn't make sense, please go back and review that. So, when the load is applied, now some of the energy is going to be taken out of the system because it's actually going to be moving the load. Therefore, when the load is applied, the motor will rotate at a slower speed. Okay. Now, if it's rotating at a slower speed, the induced back EMF is going to be smaller because it's cutting the field lines less rapidly, etc., etc. So the induced back EMF will be smaller. Now, what does that mean? Well, that means so the voltage across the motor, which is actually the voltage from the battery minus the induced back EMF. So the voltage across the motor, well, that's going to be bigger because the voltage from the battery is going to be the same, but the induced back EMF is going to be smaller. So the voltage across the motor will increase. Now, if the voltage across the motor's increased, what will happen then, V equals IR, is the current will increase. Therefore, the current will increase. I hope that makes sense. Thank you very much.